We came up with problem number 41. This problem gives us a relative frequency histogram and want to know, um, it says the blood pressure readings were given to the nearest whole number. Identify the center of the third class. So the first bar has a class from 100 to 110. The second bar represents a class from 110 to 120. The third bar represents the third class. It's between 120 and 130. Now, we want to know the center of the third class. So where would this center point be right here? Well, I'll just say 130 plus 120 and divide by 2. Just like we're finding the midpoint. 130 plus 120 divided by 2, and that'll give us 125. This histogram, we want to find the class width. So if you see, if this is, let's go a bit up this a little bit. If this is if this is 0 and this is 1, then this right in the middle of 0 and 1 is 0.5 or 1/2. Alright, so the class starts at 1/2 and then ends at 1.5. So that's still just 1 unit total. Each one of these is 1 unit. First class is from 0.5 to 1.5, and then the next class is 1.5 to 2.5, so on and so forth. So the class width is just 1 on all of those. What is the maximum number of households having the same number of television sets? Alright, so this shows television sets per household. What is the maximum number of households having the same number of television sets? Maximum number, 50. Having the same number of television sets. So 50. That's the biggest. Determine with the minimum number of households having the same number of television sets. So which one of these is the smallest? Right here. Right? And follow that over right here. That's 0 and that's 10. Halfway is 5. So the answer of 5 has nothing to do with the 5 on the horizontal axis. It's because at the smallest bar, if we trace that over to the y-axis or the vertical axis, we get 5. Alright, construct a scatter plot. A scatter plot means, so we have to click for the data table. A scatter plot, if you just put like these two, like 183 and 169, make that an ordered pair. Make each one of these an ordered pair and graph it like it was on the XY axis. Then you'll get your scatter plot. So now you may want to look at a couple of those values and pull up one of these. If all the values are going, once you have everything plotted, if everything's kind of going up, then there would be a correlation. Everything's going down. But if they're all spread out like this, see, like 183, 169. So if that's 160, that's 170, that's 180. 183 is going to be over a little bit. And then 169, that's 160, that's 170. So if you are just to graph these, make sure you're careful with the x-axis and the y-axis. It looks like they made the opponent's height, the y-axis, and the president's height, the x-axis, so you can think about that like an x and a y. And so I need to count these and make sure. I see this is, would that be 70, 80, 90? No, that wouldn't be. So this is 165, 170, 175, 180, 185, 190, and so on and so forth. And the same for the vertical scale. 165, 170, 175, 180, 185, 190, 195, 200. Alright, so 183, that's going to be, if that's 65, 70, 75, 180, 183 is going to be close to 185, so it's going to be right there. And then 169 is close to 170, so if you go up 2, then it will be one of these points here. Alright, you do that for all the points. And again, if they're kind of clumped up and if they look like this, like they're going, it's rising, then that means there is a correlation. But if they're all spread out, like the correct answer, then there's no correlation, no pattern. Alright, complete parts A through C. Which plot represents a dot plot of the data? Alright, volumes of soda. So what you do for a dot plot, I think your book says something like tally marks, and that's kind of confusing sometimes. But the way that tally marks work, if you see all these scales, you have 50, 60, 70, 80, 90. Then what you'll do is you'll come up here and you'll count, say, how many 50s do you have. There's a 50 right there. So you put 1 point at 50. Or 1 dot. It's real small, so I'm going to make that larger. So there's 1 dot here at 50. Alright? Then, if that's 55, look for 55s. There are no 55s. Look for 60s. There are no 60s. Look for 65s. There are 2 65s. Well, since there's 2 65s, you'll take and you'll put 2 dots at 65. Then you do the same thing for 70, 75, 80. Just count how many 70s there are. 1, 2, 3, 4. 4 dots. Do the same thing for the rest of the numbers and have your graph, and it has to be this one. Does the configuration of the points appear to suggest that the volumes are from a population with normal distribution? Remember, normal distribution, I told you, it starts off low, then it goes high, and back down low. Now I know that this here doesn't really go low here at 85, but it's a general shape. Even if one place doesn't look kind of like a bell curve, like real low and then high and then back low, it's still in the general shape of a bell curve. So it says yes, the population appears to have normal distribution because of the dot plot resembles a bell curve shape. Are there any outliers? Outliers are values that are not close to the middle of the set of data. So like this 85 here, those are outliers. Okay. Use the heights to construct a stem plot. Is there strong evidence suggesting that the data are not from a population having a normal distribution? The way stem plots work, you can see it looks a little confusing, but this is the first number, and then I guess for 94, so they put a 9 right there. Well, if you put a 9 here, it's going to be 10, 11, 12, 13, 14, 15. That's the first part of your number. This right here, like before, that means 94 is an item. See, they have 2 zeros here. What does that mean? That means that 10 with a 0, that's 100, is an item, and 10 with another 0 is an item. Well, look at this. 11, and you get 0, 0, 0, 5, 7. So, you look at all of your terms that start out with 1, 1, and then look at the last digit, and that goes in your table. So, so this right here stands for 110, 110, 110, then 115, 117. So first two numbers, and then the last number you put in the other column. Is there strong evidence that the data are not from a population having a normal distribution? No, they are, because you see how it starts off low and then it goes high and then back down low again. So there's not any evidence that suggests that it's not from a normal distribution. It suggests that it is from a normal distribution. So I construct a pie chart. So pie chart, what you want to do, um, if I want to construct one using these three pieces, then we're going to have one that has 20%, one that has 50%, one that has 30%. That does add up to be 100%. So the piece of pie that has 50% in it should be labeled good. See, good 50%. Excellent 20. Excellent 20%. Fair 30. Fair 30%. See, it's not the other because none of those are what they're supposed to be. What percentage of vehicles are hatchbacks? Look at the pie chart. Hatchbacks, 36%. That's the answer. Easiest problems on the test right there. Alright, find the number of people who live in single-family houses. It says that the population is 79,600. So 42% are single-family houses. 42% of the entire population of 69,600. So if we want to take 42% of that, we say 69,600 or 79,600 and multiply that times 0.42. You get 33,432. 33,432. And that's your test review. Best of luck on your test, and please email me with any questions.